Hello and welcome. Today we are talking about the FOIL method, or curses foiled again. Our objectives for today: we're going to learn how to use the FOIL method. We're going to review like terms very briefly. And we're going to learn the rule that is superior to the FOIL method. FOIL method falls under a bigger rule. Some terms we need to know. The sum of x and y. Let's look at an example of that. The sum of x and y, we're just going to add them together. And a lot of times they're going to be in parentheses. And so here we have 3 times the sum of x and y. So we might talk about that today. The sum of x and negative y. Well, it looks a lot like x minus y. But we're adding a negative. So we can also think of them as being switched around. A negative y plus an x, and that might be useful for us. We also need to know the difference between a term and an expression. So 3x is just a regular term. 3x minus 2y is an expression. It's a little bit longer. And like terms, we've talked about these before. 2x and negative 3x are like terms really just because the coefficients are followed by the same variables, not x squared, just regular old x. They have to be identical. The FOIL method is an acronym. So we're going to multiply the first terms, the outside, the inside, and the last. That works well with a lot of expressions that we're going to encounter, but it doesn't work with every one. But let's look at when it does work. When we have a plus b times the sum of c plus d. We're going to deal first with the a and the c because they're the first terms in the parentheses. So we'll write that right below it. We can imagine that there's a positive sign in front of them. And then we go to the outside terms, a again, and then d. And we can write it right beside it. Again, they're both positive, so we can use a plus sign right there. And then we're going to go to the inside terms. We're going to go to b and c. And they're also both positive. They're going to be the next terms. And then the last terms, the b and the d. They're going to round out the end of it. So that's the FOIL method in a nutshell, but there's a lot more to it. So let's look at making it negative. Some negative signs here. So we have a minus b and then the sum of negative c and d. We're going to multiply those two terms together. So our first two terms are a and negative c. And that means that we're going to multiply them, the positive times the negative, and the result is going to be a negative ac. When we go to the outside terms, a and d, they're both positive because there's not a sign there. There's a positive sign there, so both of them are positive. And then we have the inside terms. Now we have a negative b and a negative c. What happens when we multiply two negatives? That's right, we get a positive. And then our last terms, negative b and a positive d, when we multiply those, we get a negative. The negative wins, negative b, d. So we got to watch for those negatives. Those will throw you off very often. We're going to try it with regular numbers, but first we're going to try it without the FOIL method, which in this case is going to make a lot more sense. We use the FOIL method when we have to. If we just have regular old numbers, it's easier to just follow the order of operations, which tells us to work with the terms inside the parentheses first. So we have the 2 plus the 3 and the 4 minus the 5. When we add the 2 and the 3, we get 5. 4 minus 5 is negative 1. The negative times the positive loses, the negative wins. We have negative 5. Let's make sure we get negative 5 again when we do the FOIL method. And again, this is the inefficient way to do it in this case. So when we have the first terms, the 2 and the 4, we get 8. The outside terms, 2 and negative 5, we have a multiple or a positive times a negative. We're going to have negative 10. And then we have the inside terms, the 3 and the 4, both positive. We're going to have 12. And then the last terms are 3 and negative 5. That is going to give us negative 15. Okay, to check it, we have to whittle it down, so we kind of use the order of operations, and we look at the first two terms, and we're going to whittle those down. So we have 8 minus 10 gives us negative 2. Negative 2 plus 12 will give us 10 again. 10 minus 15, we're back to negative 5. So we know that the FOIL method works, and we had a little bit of foreshadowing for adding like terms. Now for something completely different. Like terms, we've talked about them before. The first set we have 2x squared and 3x squared. Definitely like terms because what comes after the coefficient in both cases, they're identical. So we can add those two together. Here we have a y and we have a y, but this is a y squared. It's a different dude. This one, it cannot be added together, these two terms. Okay, so when we combine those terms, we get 5x squared, and nothing happens over here. Here we have what looks to be different terms. We have x y squared and then y squared x. But really what the problem is that this is not in the proper order. If we're going to put it in proper order, we want to put it in alphabetical order. And so we can just move that x over there, and then we do have like terms. Here we have the x is specified as being negative, but we're going to multiply a positive times a negative. That just puts the negative sign out there. So both of these guys are like terms. Let's rearrange the first one to put it in the right order. And then let's get rid of the negative inside there. Now we can see that they're like terms even though they were before. And then we can combine. So we can add the coefficients, get 5. We can add the negative coefficients, negative 7 and the negative 6. And it becomes even more negative, negative 13. Okay, the FOIL method doesn't always work. It works really nicely when we just have two terms in parentheses, but we need to look at what's really going on. So the rule that we need to follow isn't really that hard. And let's look at this one. It has 3 terms times 3 terms over here. So we have to multiply every term in this expression times every term in this expression. That's the big rule that we're following. Every term in this expression times every term in this expression. When we do FOIL, we have that covered, but we do need to know the FOIL does not always work because we don't have first, outside, inside, last. We don't have that going on here. Okay, so it takes a while to break these down, and it's kind of a lot of busy work. And so it's easier to do it in kind of an orderly way. So we're going to start with the first term in the first expression there, or the first group. So that's 3. It's a positive 3. We're going to multiply the positive 3 times every one of these guys. And when we do that, 3 times 2, 6. 3 times negative x, negative 3x. And 3 times a y, 3y. And that one's positive. That one is negative. So we got to remember to bring those signs down. And then you don't have to write it this way, but you can if you want to. You can just write it below it and just remember that they're all supposed to be on one line, but just for the sake of organization, we're not going to do it that way. So then we have that's wrong. No, it is right. I'm sorry. We're doing the 3 times the second, forget the 3. The second term here, which is the x, because we're done with the 3. The x times every term in there. So we have x times 2, 2x, x and x, but this one's negative, this one's positive, so it's a negative x squared in the end. And then the x and the y plus xy. And then we're going to move on to the last term in this group. We did all 3, or we did these 2. Now we're going to do the negative 2y. We got to remember that that sign goes with the 2y. So the negative 2y times the 2 gives us a negative 4y. Negative 2y and a negative x. We have a negative times a negative. We get a positive 2xy. And the last thing, the negative 2y and the positive y gives us a negative 2y squared. So that's a lot. There are many terms there. We have 9 whole terms we have to put together on one line. And you don't have to show it this way if you don't want to, but this is what they look like on one line. We can condense it. We need to identify the like terms, and we just talked about that a little bit. There aren't any tricks in this one though, because the like terms should be pretty easy to see. First we have the x terms, and that's this one with the -3, this one with the 2. The coefficients go in front of the same variable, the exact same variable. Then the y terms, we have 2 of them. And then we do not have a match for this one, so that one just stays white. I didn't change the color of it. We do have an xy term. Remember, there's an imaginary 1 there. We have this xy term with the 2 in front of it, and then this one doesn't have a match, so I kept that white. And of course over here, the regular old 6, it stays the same. Now we can combine the like terms. And when we combine them, the -3x and the 2x, when we add those together, their sum is -1x. We'll just get rid of the 1. The 3y and the -4y, they go to battle, and it's a -1y in the end. And then the xy here has an imaginary 1, so that becomes a 3xy when we add it to the 2xy. And the others just come on down. They're along for the ride. There's one last step that we need to do. We're not going to get into depth with this one, but we do want to put it in standard form, and we're just not going to talk about what the standard form is today, but if we put it in standard form, we start with the x terms. It kind of goes in alphabetical order, and we start with the highest variable, and then we kind of go down from there. And this is what it looks like in standard form, and I did double check this one just in case you're wondering. So it's a lot of busy work, but sometimes we need to do that. We need to break down those barriers and multiply the terms. Okay, did we meet our objectives today? First one was to learn how to use the FOIL method. I think we got that. That's the first terms, A and the C. The outside terms, the A and the D. Inside terms, the B and the C. And the last terms, the B and the D. So that's the FOIL method, spells FOIL. To review like terms, so we just remember that 2x² and 4x² are like terms because the x² are identical. And so we can add the coefficients and we can get 6x² from those. And we learned that the FOIL rule is actually underneath a superior rule, and that is every term in the first expression must be multiplied times every term in the second expression. So the A times the D, the E, the F. The B times the D, the E, the F. And the C times the D, the E, the F. And that's where we came up with the 9 terms in a row. That is the FOIL method, or Curses Foiled Again.